Welcome. It's been a good year. Welcome back to Demopalooza. This is the Demopalooza 2025. It isn't the 25th Demopalooza, but it feels like it sometimes. We've gone numerous places with Demopalooza, and this year, why not go to the far edge since we talk about it a lot? We're in space. So Aaron?
I'm actually going to give you that.
Thanks, man. I think this will help. So we're going to go to a few slides. I wanted to talk to you a little bit about the core tenets of SUSE and core tenets of what we're doing in the space station, the International SUSE Station. All right, let's see if this works. So big part of our core tenets for deploying things at the edge is freedom of choice. So that could mean things with the partners that we have, all of the equipment and the experiments that come up to the SUSE space station. Freedom of choice includes operating systems. It includes a wide variety of different hardware platforms, different architectures, different things that we want to deploy on applications, virtual machines, containers. All of these things are all part of that freedom of choice. And it's important when we're partnering with people. We never know what they're going to bring, but we want to be able to manage it all. So freedom of choice, the big first one. Next is security, of course. From the ground up, all of our things need to be very, very secure. Think about it. If we wanted to patch things, we're going to need to actually manage a wide variety, like we said. There's also things in security that, it's tough to get some service and patches sometimes, but security is a big tenet that we need to care about because, even getting DoorDash up here is really expensive. Another piece and part of that is optimizing the hardware, right? Again, it's very expensive to come up here, so we're going to have to actually use all of this hardware very, very efficiently. So we want to be able to see what's happening with all the applications that we're using and all the technology we're putting together. So optimizing hardware and its usage, very important. Also, optimization of bandwidth, right? Again, we're way up here in space. Communications are very, very expensive. This is not just your phone call to mom. This is mission-critical stuff, literally mission-critical. So bandwidth optimization, caching things, being able to reuse the packages that we transfer, the images we transfer. So we care a lot about that. Again, that's the core tenets of everything that we do in the International SUSE Station. Aaron, why don't you talk to us a little bit?
Let's talk about what we've actually got running. Because one of the key things that we're trying to do is, much like businesses are trying to just get businesses done, we're trying to just get science done. We don't care about computers. We don't care about operating systems. The last thing we want to say is, you can't do that piece of science because we don't support that operating system or that language you want to develop in, right? We just care about science. That's all we want to do. So here's what we've put on each of our space stations to really open that up to let people develop anything they want. So the first thing is how we're going to treat hardware, right? We've got hardware that's been donated from all different vendors around the world, all different types of processors, right? x86, ARM. What we really want to do is separate hardware from the science that we need to do, right? Hardware comes and goes. You get new hardware, hardware dies, it's replaced. We want to separate those two. So what we're going to do is we're going to take all the hardware in our environment, and we're just going to treat it as a cluster and say, this is the amount of hardware we currently have, this is the amount of work we've got to do, and let the system figure it out. So let's dive down and get nerdy and really see what's running on these machines. So the first thing we need to worry about is we need to worry about storage. We need to store files. Now, we've done this for years with Longhorn. Anytime Longhorn, when you go store a file, it immediately stores at a minimum of 3 other servers, right? Like I said, we've been doing this for years. This year, we've announced and we're making big changes. The first thing, we've modified Longhorn 2. It's in pre-release right now. We'll be shipping very soon. 3 times the performance that we're getting. It's really 1 to 10, depending on what you're doing, but massive speed increases. Now, this is great, but like I said, we've got hardware from people all over the world, and much like our customers, you probably already have some storage on site, some very, very good storage. And what we are now doing is we're supporting a bunch of those existing storage vendors that are already there, and what we're allowing you to do is actually swap out that core storage with whatever storage vendor you want, or an approved certified storage vendor, of course. But now you have the choice and the option to really leverage the storage you've already got. So that's good. We talked about storage. Let's talk about actually running containers, right? So of course, we can natively run containers on this, but I want to take a minute to remind you not all containers are equal. Jeff mentioned security is a big issue, security and reliability. In order to do that, what we want to do is we want to minimize the amount of CVEs or known bugs that we allow on our space stations. So we're going to start with when we actually start to develop the apps, we're going to make sure we're starting on a secure platform. The problem is right now, if I go and I just pull Python latest, Jeff and I checked this last night, there's 112 critical and major CVEs in the upstream version of Python 3.12. Now, what's funny is that's just the top ones. There's, oh my God, 800 if you include middle and low tier, right? So we're talking hundreds and hundreds of CVEs. If you compare that to what SUSE has done and rebuilt Python on a SUSE-based operating system, there's a single CVE. Single known bug. It was found last week. I'm sure that whoever's writing the upstream code will have it fixed in a couple days, right? But that's the key is we're making sure all of those known CVEs are automatically applied to your base container images. And we're not just doing that for Python, right? We're doing that for whatever development languages you want. These are the core ones that we support that we're doing the exact same thing. We're rebuilding on solid SUSE operating systems so you get very few CVEs. Okay, now let's talk about virtual machines. So now we need the ability to not just run clusters and containers, we want virtual machines, and we want virtual machines from all different operating systems, right? We need to support a variety of different versions of Linux as well as Windows. So what we really wind up with is the ability to just take all of our hardware, pull it together, and then run whatever workloads you need to do science. It doesn't matter what the operating system is, what the container is, or what that virtual machine is. But with all of this freedom of giving your developers choice, it brings up some more issues, doesn't it? I now all of a sudden have a ton of different operating systems in my environment that I've got to manage. Jeff, what can I do with that?
Well, SUSE Manager, or formerly known as SUSE Manager, I like to say the artist, formerly known as, because, Minneapolis Prince, long story. Multi-Linux Manager is here to save us from all of the pain and suffering of managing a whole bunch of different operating systems, right? So instead of worrying about what we support, how about we are able to patch and update whatever is brought to us by our partners in the International SUSE Station. Not only that, Multi-Linux Manager, great. Patch everything, fix everything, keep it secure, and again, back to our tenant, bandwidth is important. One of the key features of Multi-Linux Manager is the ability to cache packages where they are needed most. And once it's on that side of your firewall or space, you can cache that and be very efficient in those communications. And package one time goes across the bandwidth and then is absolutely being able to deliver it to other machines. So again, coming in, being able to cache it locally, very, very good for what we want to do in the space station. But wait, there's more. So what about if something breaks? The nice thing on the other side of the coin is SUSE Linux Manager support, or SUSE Multi-Linux support. I'll get it here soon enough. But it's that single phone call for all of these operating systems and being able to get help when you need it. So a single phone call for all of this.
Yep.
I think there's another thing that we want to talk about is a recent announcement with the SUSE registry, right? So we have a private registry now talking about packages and updates and configuration management. That's one thing. Going into the container world or cloud native, we also have the need to cache and pull things through. With SUSE's private registry, we're also bandwidth friendly. We can update and store our images and containers and artifacts in a registry and also be able to cache those with a pull-through cache and secure all of it. So this is another thing that we want to talk about. We should have them stop by the booth and ask about the private registry. Now that we've got all that, the ability to actually deploy in a uniform way, getting really efficient, being able to define your deployments as code. We can leverage Fleet to not only roll out the artifacts, the containers, the security pieces, but also by defining a type, we can now repeatedly install this on any of the space stations that we have around. So define a type, push it out. Fleet will take care of taking that registry component as well and being able to deploy that to all of our space stations. So very easy to get a handle on virtual machines, containers, all of these workloads.
Perfect. So that's what we have today on all of our different space stations. We've got a nice base that we can support all these type of workloads. However, we're in the process of rolling out a brand new capability to all those space stations, which is really observability. So if we can have the slides back up for a second. Awesome. So what I want to do is I just want to set a base level before we kind of show you how observability works. I want to dig into it and kind of get nerdy and explain exactly what's happening. So observability is really about monitoring and measuring health and performance, which is great, right? That's what everybody says that it's about. But let's talk about how that actually happens. How do we get those details? How do we figure out what's in a service? So the first thing is we've got a cluster, right? We've got a bunch of nodes, and on those nodes, we've got a Kubernetes cluster. And then we're going to have workloads, right? We're going to have pods that are running, and we're going to have services that connect those pods to the outside world. So how are we going to get all this cool observation information? The first thing we want to do is we want to get information from the node. So we're going to install a node agent. And this node agent is going to do a couple things. First, it's going to look at processor and memory usage, and then we throw in an eBPF driver. And that lets us do something very cool. Not only do we see network traffic, we actually get the ability to time network traffic. So we not only understand what the communication is, we know on average how long that communication normally takes. So that means we can immediately see when things speed up or slow down. On top of that, we also get the ability to see every single process that's running on that node. So we really get full visibility on what's happening on that node. Now, since we're doing this in Kubernetes, we're going to start to really leverage Kubernetes. So we are going to tell it to, whenever it sees a change, write this to a log. And notice how my log has a time going across it? That becomes very important in just a minute. So we're logging everything based on time. And now what we're going to do is we're going to tell Kubernetes that we're going to define a daemon. So we're going to say, on every single node in our environment and any node we ever define, put those agents, so I now have full tracking. Now we're going to do the same thing for Kubernetes. We're going to install a cluster agent that's going to give us deep visibility into that cluster. So now I can see every one of these pods, and I can see exactly what's going on with that pod. And not only can I see that, I can also see everything that's going on with the service, right? So I know the communication that's going on. And it's not just for existing pods and existing services. Every new thing that comes into Kubernetes is automatically going to have observability turned on. Now, let's dive in and see what we're actually seeing on the Kubernetes level. So here, I'm creating a pod. We can see the pod get created. We can see it goes ahead and creates a container inside that pod. It goes to grab the image, and it crashes. And it doesn't pull because Aaron screwed something up, right? I got a crash back-off loop. My image name isn't right. So what do? I go in, and I edit it. And the system notes, Aaron made a change to that deployment. Now, all of a sudden, the image is able to pull, it pulls, it spins up the database, it scales, it runs down, right? So now we have a full log of what's going on, but notice something else. Remember a couple slides ago we saw that processor usage spike? Now we have context. Now we know why on that node that processor came up, because Aaron spun up a new pod. So we're starting to get real nice context across our entire system. Okay, next thing we're going to do is logs, right? We're going to automatically inject and grab logs, not just from Kubernetes and not just Kubernetes-based container logs. We're going to get the logs natively out of your application, so we're going to be able to view all those. And of course, just like everything else, it's dropped on the timeline as soon as it happens. So again, full correlation in time. So this is great. We just have a ton of information, right? We've got information coming from those nodes. We've got information coming from the containers. We've got logs. We just have a ton of information, right? And what happens, this is great, but real quickly I become overwhelmed, right? How do I use this to really find out if my systems are healthy? And that's really, to me, this is one of the things that I absolutely love about SUSE observability, is the topology view. Now, I've been doing computers forever, right? And I've done a bunch of service management stuff. And all the service management stuff that I've done before is you define what the service is, and then you can manage it. But you have to manually go, well, this is part of the service, and this is part of the service. What we do with SUSE Observability is we leverage all those Node and Kubernetes agents we've got running to let it automatically detect what's happening. So we see a request come in through a specific service. It sees the communication happening between the pods without you telling it. It automatically realizes this service contains all these different parts and components. It then lets me really just focus and throw away all the irrelevant information. Let me just see what's relevant to that service. Now, just by doing that, is this service running? Yeah, it's green. Things are cool, right? What happens when something goes wrong? It turns red. We can see here a container just crashed. We can see there's no longer network communication going to our downstream pods. Again, the entire thing didn't turn red, just the components that aren't working. How quickly can you pinpoint approximately where your problem is? Very quickly, because I can see what's affected and what's affected downstream. Now, what's great is we've got all that information that we stored before. But again, observability lets me put a focus on and just see the stuff that's relevant to this. And this is very close to the graph that I actually see. I see things were working great, and then they broke, and the timeline literally turns red. And it's like, oh my gosh, things are not working after that. Where do you guys think the problem was? Probably right before the stuff where everything broke. And this is what's great, is we can click in on that, we can drill down, and we can actually see somebody went in, made a change to the deployment, and changed the entropy from 1 to 2, and that's what broke everything. So very easy to give you full visibility on what's going on. I got to breathe. So with that, let's actually see it, right? I want to pull my friend Yaron out, and Yaron, let's see what observability actually looks like.
Thank you, Aaron. It's great to be here. So let's talk about SUSE observability. Aaron, you did a great job explaining that. If you could take the helm and actually navigate us through while I talk, that would be great. Welcome to SUSE observability, where when we enter, we see an overview of all of our services. And now I've already filtered this down into a specific cluster and namespace. What we can see is health and performance of all of these services. But where SUSE observability, of course, really shines, as Aaron explained, is our topology view. So Aaron, if you would move there, please. When we look at this, we see the world in a connected state. We see all of these services, they're communicating with each other. And what's great is that we're in a green state currently. Amazing. However, if we look at our newly released unified timeline at the bottom, we see that though we're in green now, we used to be in a deviating situation. And this is great, because previously, with SUSE observability, our timeline was only for a specific resource. Now, whichever slice you make, you can see its health. So let's go right to the start of where we saw this outage. And wait, we see our front end was down, actually, or at least deviating, meaning our customers were either experiencing latency, experiencing errors. What we also see is that the downstream service was also in a deviating state. So let's investigate that. We open its component view, and immediately we see all of the correlated data. We see its Kubernetes metadata, related resources. We see the monitors, which monitor health and performance over time. We see the correlated events, and if we scroll down, we will see the metrics. We see network throughput in this case, bytes sent, bytes received, all of this correlated over time. So let's go back up, and we actually want to see what was going wrong. So we annotate the time where actually this outage started. And what we see is when we annotate that is there was a deployment which just previously happened. So we'll go and investigate that. We open up the deployments, and what we see is we see 2 configuration change events, one at the start, one at the end. So we want to open up its change set. And we scroll down, and what we see is, okay, we deployed a new version, but the version that was deployed was not of this service. It was actually of a different service again, because we know how everything is connected, how everything is related. We're able to see those changes correlated across time, across resources. Whoa! Jeff, man, what's going on here? What did I do wrong?
Nothing to worry about. This happens every day on the International SUSE station. We just got an alert from Mission Control, and they're asking us to deploy an application.
Okay, well,
So this
let's hear it. What do we need to do?
Sure. So if we can go to the deck, I'm going to describe a little bit. All right, so the application command that we got is we're going to deploy something for our SAP team. They've got a edge integration cell that they want us to deploy, and it has also some components that it's going to talk to. We're also going to talk to a large language model, so we'll need some middleware to actually run that. Luckily, we have that in SUSE AI, as Abhinav just talked about. The other part is a custom application that we're developing that's going to integrate with some APIs. So before we get started too much, I want to talk a little bit about the dependencies, Jeroen, in the SAP Edge integration cell.
Yeah, let's hear it, Jeff.
So along with the SAP Edge integration cell, you're going to have to deploy 4 different components. One of them is Redis, the other one is Postgres, and then there will be the Cert Manager for managing SSL certificates, and MetalLB. All these components are the dependencies of the Edge integration
Yeah, but
cell.
Jeff, wait a minute, man. I've played around with this in our lab. If I pull all of these from upstream, and I don't know about you, but I thought we were talking about secure and trusted.
Yeah.
Right? Aaron, can you pull up SUSE Security, please? Let's go into our security risks and then vulnerabilities report, because I've installed this. We're looking at our lab environment. We want to filter down into each of these namespaces, so Redis, Cert Manager, MetalLB, and Postgres. And we'll wait until Aaron has typed all of that, because that's quite a number of typing. Let's apply that. These dependencies actually contain 64 vulnerabilities, and if we sort them actually, we can see that these are not like small vulnerabilities. There's actually a ton of them, pretty critical. So our CISO would kill us if we would do this. Is there a better way, Jeff?
Well, I think there is, actually.
There definitely is a better way, but before we even get there, let's just meet the requirements properly, right? Let's build a cluster, let's put the proper requirements from app collection in and just get it going.
Yeah,
right?
That sounds like a great idea. Who do we need for that?
I think we're going to actually deploy another cluster.
Should we maybe get Alejandro out here to do that, though?
I'd love that. Let's bring our SRE, Alejandro Bonilla.
Everyone.
So what we're going to have Alejandro do is we need a downstream cluster for us to run SAP Edge integration cell, and luckily they just require a Rancher downstream cluster. So let's have Alejandro go ahead and create that for us.
All right, perfect. So we're going to go ahead and click Create, then go into SUSE Virtualization, Harvester here, and Rancher Prime for now. Then click on our host cluster. Then we're going to provide a name for the Edge integration cell, and then just set the virtual machine resources, including a pool name. We want 3 nodes in that cluster. We'll set the CPU, RAM, and the namespace. Of course, we're going to choose /15 as our image, and then VLAN1 for our network configuration. We're going to scroll up into the Show Advanced section so that we can then use a cloud config template that has all the requirements for a virtual machine. Which is going to do a package installation, just inject some commands, and then create my user. And then we're going to scroll down to the Kubernetes version that is tested for Edge integration cell 128. And then we're going to choose the Harvester cloud provider. With the Harvester cloud provider, it gives us the load balancing service, the CSI pass-through for persistent volumes, And there are a topology awareness, so that our hosts are completely aware pretty much for HA purposes. And then we're going to add a label for this cluster called app edge integration cell, so that our fleet bundle will then deploy on this cluster. We'll go ahead and click create. All right.
Awesome, cool. So that's created. One of the things that I want to point out is when he went to that harvester provisioner and he mentioned that the load balancer is automatically provisioned, Jeff said there was a requirement for metal LB. Does that mean we no longer need metal LB?
No, you no longer need it, because the cloud provider interface provides all these features that are just make SUSE virtualization cloud native, and it just provides everything you need for your virtual cluster.
Right, all downstream clusters automatically get IP addresses, they get storage without absolutely anything.
You're correct.
So why don't we go in and see if that's actually cleaner? Let's take a look. It's probably had a chance to deploy. Let's take a look at Fleet and see what those apps look like.
Yeah, let's do that. Because this sounds great, right? He applied the label, so clusters up. Let's go to Fleet. So when we look at Fleet, we see our edge integration shell, and it's actually green. Let's click in it. And we see Cert Manager, Postgres, and Redis have been deployed. As Aaron said, we don't need Metal LB because SUSE virtualization provides it. So let's go into SUSE Security, because these apps are actually now deployed. So go into the edge integration cell, we choose the SUSE Security menu item, and then click on the box, which will take us into SUSE Security. And of course, we go to our vulnerabilities report. And what we want to do is we, again, want to filter it down. Let's choose all the namespaces just to be secure. So Metal LB, Postgres, Redis, and Cert Manager. Yes, click apply, please. Man, there's one vulnerability. So we went down from 64 to 1 vulnerability just by using application collection instead of upstream. This is great. This is what we can sell. Our CISO will be happy. And that one vulnerability, that was only 2 weeks old, so I'm sure that in a week's time, we'll actually be down to 0 vulnerabilities again, and we'll be running our edge integration cell in a very secure way. We deployed this on SUSE virtualization. And as Aaron said, can we
Observe.
Yeah,
let me drive.
Right? That's what you brought me out for. And of course, the answer is?
Yes.
Audience? Yes, we can. So let's bring up virtualization, observability. Go into the hamburger menu, and let's have a look at what SUSE virtualization actually shows in SUSE observability. We scroll down, we go into SUSE virtualization, and what we see is we have multiple different options to choose from: virtual machines, launchers, controllers, and hosts. So we want to take a look at the virtual machines, because that's what we created. And what we see is we're actually observing a ton of virtual machines at the moment. We're observing a CentOS machine, Liberty, we're observing some Red Hat machines, a SLES machine, and even a Windows server. So that's great, right? But if we can look at topology, we actually see how these are running, where these are running. So we see for each of these virtual machines on which hosts they're actually deployed, so which host systems. And they're all green, which is great. So let's have a look at the SLES machine. We open its component view, and like any other resource that you see in SUSE observability, you see the metadata, you see correlated events, you see metrics like CPU usage, memory usage, and if we scroll even further down, we see things like I/O times, I/O operations, and the traffic on the disks, which are actually much needed performance metrics for a virtual machine. If we scroll up, we actually also see on our timeline that there was an outage. So let's click into that, because something happened to that virtual machine at some point. We see at the center of that outage, there were some changes happening, actually, and we want to see the last change. What happened to this machine? We scroll down. Al, what did you do, man? You saw how busy this machine was. You scaled down the cores? You can't do that. So let's go back into SUSE virtualization to actually try to fix this. And what we've made easy is actually to go from SUSE observability to SUSE virtualization. You just click those three dots, click Manage Your Virtual Machine, and if you click that, we're back into SUSE virtualization. We can actually adjust that change that Al made. Isn't that great?
So I'm a Kubernetes fanatic, like a lot of you guys, and one of the things that I love most about Kubernetes, don't giggle, is namespaces, right? Namespaces are fantastic. What a namespace allows me to do is have my own little world to do work in, and I can create my own world and delete it as much as I want. So here I've created a namespace for us to do some development in. So I'm going to throw some things in there. I'm going to put a service in there. I'm going to put some pods. I'm going to put security. And I'm going to put some secrets. That's my little world. Now, what's great is I create namespaces throughout the day, and when I'm done with them, or more likely I screw something up, you throw away the namespace, and it disappears. When a namespace is created, the resources that are taken are tiny. The only resources that are taken are the resources for the pods and the services that are actually running. The great thing is when I'm done with that and I throw it away and I delete it, it deletes everything in that namespace and I return those resources, right? So it's very, very resource friendly. This is why developers love it, because they can create environments, do some work, throw them away, restart. When you combine this with GitOps, this is where things get cool, because now when I create that namespace, I can say, give me a small clone of production. So I have my own environment that looks like production that I can do development in. And in fact, I can pop up another namespace that has the exact same components, but because they're in different namespaces, they're in different separate worlds, right? And I can develop on my own, Jeff can develop on my own, we're completely isolated. But there's a problem. The problem is Kubernetes is very, very flexible. What I mean by that is one of my other favorite things in Kubernetes is the ability to create Kubernetes operators and Kubernetes CRDs, which let me fundamentally change the way Kubernetes works and processes information. I can customize it for my own needs. But when I make that change goes beyond my namespace, right? It's actually affecting all Kubernetes clusters that are in that cluster. So that CRD change that I made affects every other namespace. Wow. That means I no longer have that layer of isolation that I have with namespaces, and it's not great for really developing some custom stuff. So what I need is a temporary, tiny Kubernetes cluster that I can create CRDs and Kubernetes operators and develop in. But in order to do that, we just had Alejandro show us this. And what does he need to do to create a new cluster for me? He would go to SUSE virtualization, and he'd say, all right, allocate 8 gigs of RAM, put an operating system on this machine. There's a whole bunch of overhead there, right? I haven't done any work yet, and we're already consuming 8 gigs of RAM. There's got to be a better way. So what we can do is let's really just focus on K3S for a minute. If we take K3S and we just put K3S inside of a container, we can get that thing down to under a gig in size, right? And then we can actually spin that up, and we will wind up with a full running cluster well under a gig of RAM. So that's great, much less resources. I'm no longer pre-allocating 8 gigs of RAM for VMs or anything like that, and I can do my development. Now we're talking Kubernetes, right? So what do we want to do? We're going to take that container, throw it inside of a pod, and now we need a Kubernetes cluster to run this on, right? So we can run this on the main Kubernetes cluster that we've been running all along. So we actually have a Kubernetes cluster running inside of another Kubernetes cluster in less than a gig of RAM. And so what really becomes cool is when we zoom in on this Kubernetes cluster, I've got a whole bunch of tiny little isolated Kubernetes clusters that can come and go throughout the day. My developers can develop that custom code. It doesn't affect anyone. I really get the best of both worlds. right? So that's great. I can have a ton of these different Kubernetes clusters. So I've got Kubernetes running on top of Kubernetes clusters with virtual clusters. But then what's that cluster running on? Of course, another Kubernetes cluster, right? So it's Kubernetes clusters all the way down. This is one of the cool things that we just announced was SUSE virtual clusters. What I'd like to do is, Al, can we actually see what this thing looks like? So this is very early preview. I really want to thank the developers. They just got a UI for us last week so that we could show this, but this is some of the funnest code that we've been playing with for the past week.
All right, yeah, let's click Create and choose K through K as our provider. Once we choose K through K as our provider, in our Ampere Galaxy host cluster, we're going to click Install K through K, which is going to set up the K through K controller, which is going to allow us to manage and install our virtual clusters. And then we're going to call this a SUSECON Nova, and just set the virtual cluster servers to 3 for a highly available cluster. And that's really all we have to do. We'll go ahead and click Create. While that's creating, what we can do is go into the host cluster and then choose the K through K system and K through K SUSECON Nova namespaces and click on workloads. And that'll give us our SUSECON Nova server pods that are creating our virtual cluster.
Cool. So in a couple minutes, that virtual cluster will completely be up and spinning. That's awesome, but you know what my next question is going to be.
Can we observe it?
Observe.
All right.
Yes, we can.
Yes, we can.
So let's take a look at virtual clusters, because Al created the nice one. We go into a hamburger menu, and what we select is clusters. Why? Because virtual clusters are, like Aaron explained, just clusters. So we see actually a bunch of them running, and we see that nice SUSECON cluster at the bottom, which is actually in a green state. You saw also last year's SUSECON cluster, which was a real one, but this is a virtual one. So let's get into that to actually see whether it's any different from what we normally see. And again, it's just a cluster. It's got its cluster metadata, its cluster-related resources, events happening. We see the nodes in the cluster, which is actually one. Sounds great, right? We've got one node in that cluster at least. Resource usage, Kubernetes CPU and memory, all of those are there. Let's take a look at the related resource. We see a bunch of pods running in this cluster. So we see the SUSE observability agent, core DNS, great, and we see cattle and rancher and fleet, meaning this cluster is actually managed by SUSE Rancher Prime. That's great. So let's take a slightly different perspective on this cluster, because how is it actually running? Go into our hamburger menu and actually look at the servers of Kubernetes virtual clusters. And we see that there's actually 3 different servers running, as Al correctly actually created. A server 0, a server 1, and a server 2. And we see they're actually hosted in our far edge cluster. They host it in a namespace, and they're all part of this virtual cluster. So let's dive into one of these servers. And what we see is this server, it's a pod. It's not a real thing, it's just a workload in that host cluster. We see all of its pod metadata, we see the pod events, we see the logs of this pod, and we see metrics. And if we go into the log, if we scroll down indeed, we see the metrics. Now, let's have a look at what this pod is actually doing, because we want to see, right? So we can go into the logs, and what we see is actually all of the standard Kubernetes K3s logs that are captured by this pod. And we see it's actually K3s, right? It says starting K3s 132.1, which is great. It's a cluster running in a cluster. Amazing. let's take another perspective. We see all of the events also captured. We see the containers were started, the pods were running, we created some persistent volumes. So everything you need to actually observe a virtual cluster is there. But how is this actually built up? Because it sounds very complex, right? So to do that, we go into our action menu and we want to show the virtual cluster topology, because that's what actually shows you how it's built up. And what we see at the bottom is we have this machine, part of our far edge cluster, that's hosting 3 K3K clusters, the server 0, server 1, and server 2, which are those pods that we just were looking at. Those actually expose a virtual node. So not a real node, a virtual node. And on that node, there's actually a bunch of virtual pods running. So we see those pods that we just mentioned before. And what we see is each of these pods is not actually running in that virtual node. It's running on that host cluster, so they're mirrored on the bottom layer. So while we think they're actually part of that virtual cluster, they're actually hosted on the host cluster. So it's a great technology, actually, which helps you isolate necessities, but we're still hosted on that cluster.
All right, we're going to speed it up here. So back to the slides a little bit. We're going to dig into that application. We're talking about SAP Edge Integration Cell. We're talking about the large language model and a custom application in the middle. But what I really need to run this is a GPU. And so, Al, I would love to ask if you can provision a virtual GPU in a cluster for us to use.
You got it.
Let's go back to this.
Right, so let me have my screen here. Perfect, so what we'll do is modify our current SUSECON SUSE AI cluster. And what we do is simply click Edit Config. Then we scroll down into the Show Advanced section. And we click Add in our vGPU section. I have several already provisioned in SUSE virtualization. All I have to do is allocate them. I will choose this one that's 4Q. That's specific for CUDA. And we just click Save.
And that's it.
Done.
That's it.
Awesome.
Great.
All right, so those other components we were talking about, right? So we've got now the large language model and something to run inference on top of it.
So we've got now a cluster with a GPU in it, right? Al just allocated that for us. We needed Ollama, no problem getting Ollama. We just pointed to the application collection version of Ollama. We got that secure, reliable version. But now let's talk about AI security, right? You and I stay on top of AI big time, and
well, there's a lot of things out there, and a lot of things that people are talking about, and a lot of big events, and we've really sought deeply some things. So let me see if I can point out a little bit of the application here for the security piece.
okay.
All right, so this is our cluster, Aaron. And we see on the left-hand side, you've got your AI reasoning agent. This is that custom application that we've built. It's going out, it's deployed in the cluster. It's actually going out to several API services, right? So if you go into SUSE Security, you can see that there's the actual application. We can take a look at the locations it's going out to consume some of these API resources. Notice anything?
So that's the key. It automatically profiled our application, and it's seeing that our application's talking to DeepSeek and to various other models, which is probably not allowed by our corporate policy.
Right, so new vector is always on. What's nice is our security team gave us, remember Aaron talked about a CRD. So this is going in, we're gonna take a CRD, which is a custom resource definition for the security. We're actually gonna pull that security in as code, and this is a known good list of the URLs that we can go to. Corporate policy said we can't go out to DeepSeek, so we're not gonna include that in the list. We'll go ahead and import that. You'll see that it's imported these rules, and it has a known good list of URLs. Once we've applied that, we can go back into SUSE Security and hit refresh. At that point, you'll see that it has put the application into protect mode. Remember, Aaron said it's always on, always learning. Now that it's in protect mode, it will keep from learning any new resources, whether those are services or end connections on the network. Here you can see the processes that are running and the network rules. The last thing we'll do is take those things that it learned earlier when it was always learning. We're going to actually delete those DNS rules, and then we'll refresh the network. So let's scroll to the bottom. And that one that we want, you'd think it would be the bottom one. It's actually 10153, the one above it. It's going to external any port SSL applications. So click 10153. And then on the right-hand side, you'll see a little trash can.
Yeah.
We'll hit delete. It'll say, are you sure? Go ahead and say OK. And then we'll have to save this so it'll re-affect the policy. Click Save, deploy that policy. And now we should have different things that we see from the network traffic. So we can go back to the view, click Clear. It'll clear out what it knew before. Hit Refresh on this screen. And we should see, okay, so there's the AI reasoning. You see it's green, it's in protect mode, and then click on the external traffic, and we'll see that a couple things are being denied. So this is a way to put boundaries around your AI applications that you're deploying. And then go ahead and look at the security events, and any exception to those rules is logged, which means that you can have complete proof that this is actually working and let people know, yes, it's possible to secure the edges. So,
Cool.
Finally. Thanks.
So can we observe?
Yes,
We can. Pull up the screen. So we're actually looking at one of the nodes now that has a GPU attached to it. So, and what we see is we see a bunch of metrics, but if we go into our metrics tab, we actually see GPU power consumption and GPU temperature immediately monitored and observed by SUSE observability. So we see it over time and current. If we go down, we also see the frame buffer memory use, GPU utilization, tensor core utilization, which is great, right? We see the GPU, but can we see more? Yes. We go into our GenAI observability. We actually want to look at our LLM system. So we look at Olama that was deployed, and what we can see immediately on the dashboard is we're actually consuming tokens from the LLM, but we also see that this LLM is actually costing us money. So it's right back at where Rick from IDC actually said, you need to be able to observe your AI because it is costing you money. And you can only see that with SUSE observability.
So you can see it.
You can.
And it's important because tokens, you know, the currency of use in large language models, there's input tokens, there's output tokens. All of those tokens you can equate to a cost, right?
Yeah. And those tokens, they're just words, right?
Split up words, they could be sentences, it depends on the language, but that's all part of why it's important to see what's happening with your AI application. To know when you need to scale it, know how it's affected by different models, the changes in models, your prompts that you're pushing in, whether you're efficient or not. This is expensive hardware. Having that visibility is key to be able to run AI applications efficiently.
So that's why I need to pay for any LLM out in the internet, basically.
You know, you can actually run all of this privately, and that's why SUSE AI is so important. The ability to run this on your hardware, keep your data inside, and be able to plug the holes around it in case there's something inside that you don't know. So this is important. What we'd like to do is probably wrap up Demopalooza because we're a little over time.
Of course.
We want to urge you to come to the technology showcase. Ask us about all of these things. Have some deep conversations. We're ready to share what we know and this ever-changing journey that is expensive. And you want to be able to maximize those costs, especially when you're at the International SUSE station. So we're ready for launch.
Yep, thanks a lot for attending.
I think we had John Pugh on a remote session. Wasn't he on vacation?
Yeah, he was actually on vacation. That's
lunar holiday. Hey, John, how are things? What's the view of Demopalooza this year from your vantage point? I think he says it's all systems go.
Yeah.